Hello, we'll revise the big data analytics and ubiquitous computing, where we had seen big data analytics. First, we had discussed about what is big data and how it been termed with the help of volume of the data, variety of the data, velocity and veracity and value of the data. Then the main part of the ecosystem of the big data and the component, we can say it's a data analytics technologies, which is like big business intelligence, cloud computing, and then visualization, chart and preparation. So data analytics, technology, and visualization are the three main component and of the ecosystem of big data. Then Apache Spark is a kind of unified analytics system. Why it is unified and large scale data processing? Because it actually supports both stream and batch processing, and it is based upon the directed acyclic graph for the scheduling purpose and optimization of the query and the physical engine. Then it is easy for using and writing the code on Java, Scala, and Python. Then Spark offers high speed, and it is also having the 80 plus high operator, which is help you to build a parallel application. Then we had seen why it is said to be unified, because it runs a stream, batch, and interactive process all together. Then it is having composability in programming library, where for big data, and it encourages the development of interoperable libraries. Then it also provides SQL and machine learning and streaming library in the Spark. So in this code, we had seen SQL and K-means model, and the uh, real-time analytics for Twitter utility was there. Then here, this shows that the how the response time, throughput, and the response time for the SQL streaming and machine learning works better for the RDD resilient distributed data set of Spark over the other systems. Next, we had discussed the Spark architecture, where we had seen it is simple master-slave architecture for the cluster management, where it has the resilient distributed data set, and directed acyclic graph was there for fundamental management of Spark context, and cluster manager was there, and worker node do the caching and task management. Then RDD we had discussed, and how the driver node passes the main task of processing to the worker node, which processes the main program on the RAM itself for distributed memory abstraction performed on the in memory, means RAM itself. We had seen how it performs better. We had discussed about Spark runtime, that how the driver launches the program and how it collects from the distributed file system and then do the RAM based in memory processing. Then we had discussed in detail about the narrow dependency and wide dependencies of RDD. We had discussed how RDD was being supported by directed acyclic graph, because RDD forms a directed acyclic graph for processing, and it uses the narrow dependency and the wide dependency for doing the stage based analysis. And then you have the boundary analysis for the stage analysis. Then we had seen how the scheduling of the different partition of the RDD was there. Then we had seen Apache Spark actually support SQL data frames, machine learning library. It also support graphics. It also support streaming, and it can run over the Hadoop, Mesos, Kubernetes standalone applications. Then it can have work as a standard cluster mode on EC2, Hadoop Yarn, and Kubernetes. And it can also help you access the data from HDFS, Cassandra, HBase, Hive, etc. So we had discussed the word count example and pi estimation, where we had seen Java RDD and flat map type of function. And then Spark SQL, how it integrate the SQL with the code, where it can process simple query of SQL, and the integration for the uniform data accessing, and it can have query for join and analysis part, Hive integration we had seen connectivity with JDBC and ODBC for business intelligence. Then we had discussed how the data frame API was working in the Java based RDD analysis. We had seen discussed about the Spark streaming similar to the batch processing, and it this was the example for the Twitter analysis for the Spark searching the Spark string in the code in the tweets, and with the time lag of 5 seconds. Then it reuses the code for batch processing, where you can do the analysis with the simple batch processing code as well for the historical data that you had kept, and you can do the real data comparison with the historical data, means old data. You can compare. Next, we had seen and discussed about the graphics, how the Spark provides graphics based parallel algorithm for page rank component analysis, connected component analysis, label propagation, then strongly connected component analysis, triangle count. We had discussed about the machine learning library, where you can have classification, regression, decision tree recommendation, and clustering and topic modeling. And we had discussed frequent item set, association rule, and sequence pattern mining in detail. So first we have to understand what is FP growth for the recommendation purpose. It actually calculates frequent items, and it do the suffix tree analysis, and it actually provides you the FP tree in the as the end, and it also provides you output as the association rules. We had discussed how the parallel FP growth was being embedded in the machine learning library, and it provides the scalable architecture and monitoring purpose and all these mining purpose. Then we had seen and discussed this example in detail, where we had seen how the FP growth was being parallelized with MapReduce. Then we had discussed how the flow diagram of MapReduce working as the flow of the input data, then intermediate group list was being generated. Thereafter, temporary answers being generated, and final result was being generated. So how the three MapReduce was been working for the doing parallel computing. First for the uh, grouping, second one for the uh, temporary answers, and third one for the final results for the aggregation purpose. Then we had seen the parameters of the FP growth, which are minimum support, which are minimum confidence. We had also seen the FP growth model provides the frequent item analysis and association rules. Then this was the code that we had discussed for parallel FP growth, PFP. We had discussed ubiquitous computing, how the edge computing, cloud computing works together. Ubiquitous computing was like anywhere, anytime computing at any device and any location, and with the any format. Then edge computing is a kind of distributed computing, and it provides data closer to the user, means how it is somewhat different from the cloud computing, which is based on the for work for the big data, but the edge computing work for the instant data. We had already discussed content delivery network and Akamai CDN, Akamai Facebook detail in unit 4. Then cloudlet, how it works for the data center in a small box, means for a locality of analysis, where you need high intensive computing for the smaller device. So large device which is having too much backup for the battery and power consumption. So large device provides the content to the smaller device with efficiency, so that the smaller device mobile would not drain easily. Then we had discussed about the fog computing, which is subset and the part of the cloud computing architecture, and how it helps the cloud computing for doing the edge analysis. Edge it provides edge computing within the cloud computing itself. Then we had discussed about the Internet of Things, that it works with the sensor, software, and technology of the things for exchanging the data and the communicating with the devices. Examples are smart home, smart city for the real time data analytics. And we had seen this is Internet of Things are creating some issues of information explosion or data delusions, means large amount of data flood was there and information flood was there from the sensors, and it is having the evergreen increasing and electronic exchanges per unit time, means it's unmanageable amount of data was being growth, and you need efficient power of computing. Thus we had discussed virtualization, and in the virtualization we had discussed two type of virtualization: full virtualization, para virtualization. We had seen how the virtualization works for the application and workspace. Then we had seen service virtualization. We had discussed about memory virtualization, virtual memory. Then we had discussed storage virtualization, distributed file system, and then virtual file system. We had discussed storage hypervisor. We had discussed. We had discussed virtual disk. We had discussed data virtualization, database virtualization, network virtualization, virtual private network. We had discussed teleconferencing, video conference could be helpful for a webcam. It could work with microphone, speaker, internet, all are required for the video conference. Then we had seen advanced form as web conference, which is based upon the internet and cloud, and also supported by Web 2.0, and well known for the Google Meet, Skype, Microsoft Team, for doing many sender and many receiver type of communication for web near webcast, podcast, web meeting. Then we had discussed virtual events in detail, where we had discussed about the aims of virtual event for creating online experience for the physical meeting, and it is based upon the live stream online on demand computing. It has some issues of echoing of sound, like audio video logistic was required. Some of the time network bandwidth issue was there. So we had discussed 2D virtual event for edited collaged photo over this. Then we had seen how the virtual degree distribution could be possible for a convocation. Then we had seen how virtual addressing could be possible in 2D virtual event. Then we had seen live video in the 3D virtualization. So this person was looking at the video on the screen with for the live video analysis. Then we had seen 3D virtual event, that decoration could be proper. This man was moving in this gallery, then the decoration should be proper. Then you can have poster session for the virtual event. Then you can go to the near to the poster and click, and the PDF will open and you can read the PDF. Then you can have different halls for doing the different rooms for the different poster sessions. So the algebra and geometric analysis, and then you can have another room as another hall was there. Then you can have the gathering, same you can talk with these people like you talk in the video conferencing, so they can hear you your voice and they can also speak, and you can have the discussion for the virtual gathering. Then you can have the recreation location where this person can move and see the recreation things going around you. Then you can have the virtual dancing with the mouse and keyboards. You can do the dancing as well in the 3D virtual event. Then you can parallelly have the live streaming for the analysis and the video type of management thing, that the professor could speak in the parallelly for the live streaming. Then you have the another type advanced form, which is a hybrid event, where the physical in person was also there and the virtual online component was also there. Then this was the example that we had seen, that this could have the landing page where you can have photo booth, chat, help desk, you can have auditorium and mosaic photo. Then you can click a photo booth photo. Then you can have the help chat in the front end. The help chat, we had seen how it works in the back end. We had seen how you can have a mosaic photo, and this was the mosaic photo that we are talking, that small persons are looking behind the photo. And you can have a special effects of blowing flower like effect and more type of thing. Then you can have a welcome webcast video could also be possible. Then you can have virtual addressing from the physical location itself. Then you can have the remote connectivity and remote addressing as well from the remote location. We have seen how the virtual degree distribution could possible. We had seen how the physical degree distribution could also possible at the same location. Then we had seen differences of then thanks a lot.